Dear viewers, we have been joined by Dr. Badr Al-Anzi, who has a PhD in chemical engineering and is the head of the ETM at KU. Good evening.
Good evening to you, and happy Ramadan to all of you.
Thank you so much, Dr. Badr, and of course, Ramadan Mubarak to you and your family.
Thank you.
Thank you. So to start off, what is desalination?
Well, simply desalination is what helps us to get potable water from seawater. So it extracts fresh water from seawater through desalination processes. So it is considered as a water treatment. So it also removes impurities associated with seawater. So it is also a very important process that really gives us the water that we enjoy. And therefore it needs very, important pre-treatment. Now, desalination processes are divided in different processes. Now, what we have in Kuwait can be divided into thermal processes like multi-stage flash and multi-effect desalination, MED and MSF. And also we have a membrane-based technology called reverse osmosis. So the primary products of desalination is potable water, and also we use this potable water or very low salinity water to produce electricity from water through treatment plants and boilers, and then introduce the steam into turbines to generate electricity. So we get potable water and electricity for the people to enjoy.
And both are, Doctor, very, very important to just living on Earth, I think. So, Doctor, what are the advantages and disadvantages of desalination? Maybe you did mention a few advantages, which is water that we can drink.
Yeah, I mean, for this part of the world, like the GCC, since we don't have any freshwater resources like ponds, rivers, due to the climate that we're in. So getting fresh water from seawater is very important. That's a huge advantage. And also from that process itself, desalination, we get electricity, 100% of our electricity from desalination. So these are really the very important and main advantages from desalination. And not just the Kuwait, GCC, and now most of the world actually now, even in USA, they are actually built in 2014, one of the largest desalination plants in the world in California.
That's great. So, Doctor, how do you make desalination more efficient? What can you do with that?
Well, desalination gives you that very important products, but also it pollutes the environment, and it's very expensive. Now, to make it efficient, there are, several really steps. For example, to operate it in a good manner, adhering, to the manual and the instructions, meaning that, once you do it properly or the operation is proper, this will prolong the life of desalination, and that will definitely increase the efficiency of desalination. Also, to the people out there in Kuwait, cutting down consumption is very important to desalination, because this will reduce the stress on desalination. So this is another step that we can help to improve desalination. Maintenance is very important, of course, to keep it clean and reduce the scaling. We get sometimes, or most of the time, scaling from the seawater, and maintaining desalination will keep it going to produce such precious pieces of potable water. Proper pre-treatment is also very important to enhance the performance of desalination. For example, the anti-scalant chemicals are added at the beginning, anti-foaming, the seawater tends to form foam, and oxygen scavenger removal to reduce corrosion. Another step is switching to more efficient technologies, like the Kuwait used to be 100% MSF thermal. Now it's gradually switching towards which is more efficient. Exploring other alternatives through research and development. For example, hopefully in the future, we see solar energy being used along with with the conventional fossil fuel. So these are few steps that help out in improving or enhancing the efficiency of desalination. Yeah.
So desalination, as we're understanding, has so much advantages, but is there any way that we can also save energy in this process?
Yeah, I mean, since in desalination, it produces water and energy, so if the people reduces energy, that would definitely help in cutting down on the energy that is produced by desalination, which is very helpful. And during the summer, I think you see the gauge or the meter that is along the Fifth Ring Road at this tall building, and it shows the load, approaching the alarming red zone. So cutting down in our consumption is important, and also exploring, as I said, alternative energies like solar, for example, in the future. If we can have it integrated with the conventional fossil fuel, it'd be great. And this will help reduce the energy or save energy, of course.
Of course, Doctor, thank you so much for all this information. So now moving on to another topic, I'm guessing, what is ICP and how can this show promising results?
Well, ICP is, the definition of ICP is ion concentration polarization. And it is a novel electrochemical desalination technology. It emerged within the last decade as a viable option for brine desalination. Now, when we say brine desalination, when we say that, desalination produces waste that we don't want. I call it unwanted product, but it's produced along with, the potable water now, and we have to deal with it. So we have to manage it. So ICP helps to manage this waste, which is the rejected brine, into we use it to produce salt and also low salinity water. But before we go to talk about the salt and the low salinity water, this ICP is different from other electrochemical desalination like the electrodialysis. It uses a unipolar membrane instead of bipolar membrane. I'm not going to go into details because it's more scientific. But if we use this as a post-treatment, which means after desalination, it will take the brine, and instead of this brine being discharged into the most vulnerable part of our coastal line, we take that brine away, introduce it to ICP or even ED, the conventional system, and produce dry salt or wet salt. Now, the dry salt is used for edible salt, basically. And the wet one is used by refineries to produce some chemicals. Along with that, we produce low salinity potable water. So we're taking the brine, protecting our environment, and producing salt that we can sell, and also low salinity water that we can use in different purposes. So it is really advantages to have such technology.
Definitely, so much advantages, and I'm guessing, Doctor, that answers the question I wanted to ask about the uses for ICP. So can you tell us how such an invention how such an invention could project on the environment? Yeah,
of course, this technology really has many advantages over the conventional AD. For example, it is more efficient than the ED, the other electrochemical desalination like electrodialysis. It is less susceptible to fouling, and it uses small footprint. Now, basically, ICP desalination is potentially capable of achieving both pre-treatment and brine salinity production. So we can use it as pre-treatment to desalination or post-treatment, okay? And it removes particles, cells, oil droplets, TSS, which is the total suspended solids, along with the salt ions. So it is really beneficial, especially when we couple it with desalination, when we produce waste like brine. We're producing a lot of brine because people need potable water to reduce. We need to reduce the deficit between supply and demand,
Of course.
And this will help us to manage the brine really rejected by desalination. Also, it really removes multivalent ions that cause corrosion and scaling in desalination.
Perfect. There's so much to know about these inventions that we do use on a day-to-day basis. So, Doctor, when this method of getting water is finalized, will it be costly to the country in any way?
If you talk about the ICP and ED post-treatment, I think definitely will cost some money, but the advantages and benefits of implementing such technologies will outweigh the cost of the process. When you protect your precious resource, the coastal line of Kuwait, where we get our food from and our water from, and it's the place where we have fun and a place of recreation. Even if it costs a little bit, it will definitely outweigh the damage that the brine could do to this precious, the fish kill that we had a few years ago. So it's okay. I mean, it's okay to cost some money, but it is beneficial and imperative to have some technologies to protect our environment and precious resource.
So hopefully it's resources put in the right place. Thank you so much, Dr. Badr, for all the information you have given us today.
You're most welcome.
Thank you. Dear viewers, we had with us Dr. Badr Al-Anzi, who has a PhD in chemical engineering and is the head of ETM at KU.